Okay, these videos will be over the linear versus nonlinear functions. Okay, we're just taking notes in class, so if you're absent or if you just want to look back at the videos to help you catch up. Okay, linear versus nonlinear functions. I first wanted to look at linear functions for a bit. Okay, a linear function is just a line, okay, and we've been doing these all year. Here's an example of an equation of a linear function, its graph, and its data table. Okay, this is all three pieces of this linear function. Just kind of as a reminder, the slope between points on a graph of a line are always the same. And I know you know that, but this is just kind of review. So if I wanted to find the slope of the line between points, I could go from 0, 2 to 2, 3. I could rise 1, run 2. So figuring out my slope there is 1 over 2. Okay, from 0.23 to 86, I could think of it as going up 3 over 6. Okay, up 3 spaces over 6 spaces. So that'd be rising 3, running 6. Now that reduces to 1/2. Okay, between 8, 6 and 10, 7, okay, it's still the same. Up 1 over 2. Rise 1, run 2. Okay, so no matter where you find your slope on a graph, it's always the same. You may have to reduce, okay, but it's always the same. Okay, and I wanted to remind you of that because I want you to think about the data table. In a data table, it doesn't matter which points you use. Okay, remember, this is the same relationship as the graph we just looked at. So to find the slope of a data table, it's change in your y values over the change in your x values. Okay, so if we're looking at the first 2 points, okay, 0, 2, and 2, 3, the change in y is 1, the change in x is 2. So we get 1/2. Okay, same points as the graph before. From 2, 3 to 8, 6, the change in y, okay, it's going up 3. The change in x, it's going up 6. Okay, so that would be change in y is 3, change in x is 6. That reduces to 1/2. Okay, the last 2 points, 6 to 7, changes by 1. 8 to 10 is a change of 2. So if we figured out the slope there, it would still be 1/2. Okay, so it doesn't matter where we find the slope when we have a line. Okay, regardless if we're looking at the graph or the data table, as long as we reduce. Okay, let's see what happens when we look at a nonlinear function. Okay, we have a nonlinear function. You've never done these unless you had them on your learning path. Okay, like y equals x squared. Okay, here's the equation. Here's the graph. Here's the data table. If I start trying to find slope, it's really not quite the same as slope, but I want to call it that. Between sets of points, look what happens. Okay, between 0, 0 and 1, 1, I'm going to go up 1 over 1. Okay, so my slope is 1. Between 1, 1 and 2, 4, I'm going up 3 over 1. Okay, so my slope is 3 over 1, which equals 3. See, those are different. Okay, same with the data table. Change in y over change in x. Okay, this is the same coordinates on my data table as I have up here. It's just looking at it a different way. Okay, so between the first 2 points, from 0 to 1, my y's go up 1. From 0 to 1 for my x's go up 1. So change in y over change of x is 1 divided by 1, or 1. Okay, my second 2 set of points, from 1 to 4, my y's increased by 3. From 1 to 2, my x's increased by 1. So my change in y over change of x is 3 over 1, or 3. Okay, the point is, when we had the linear function, either looking at the graph or the data table, no matter where we found the slopes, they were always the same. Okay, when it's a line, the slopes are the same no matter where you are. And no matter if you're looking at a graph or a data table. Okay, but when we looked at a non-linear function, okay, which doesn't make a line, okay, we're going to get different slopes. So first thing I want you to know, when you have a linear function, the slope, sometimes they call slope rate of change, is constant. Okay, that's always the same. Okay, it doesn't matter if you're looking at points on a graph or points on a data table. So as far as our topic, linear versus nonlinear, okay, a graph is a linear function if it's a straight line. Okay, that's pretty easy. Linear line. Keep in mind it's not a function if it's vertical, because a vertical line would fail the vertical line test. Okay, a data table is a linear function. So you're not going to have a picture to look at. So if you're looking at a data table is a linear function if the slopes between every set of points are all equal to each other. So let's back up just a second so I can explain this better. So with the linear 1/2 x plus 2, y equals 1/2 x plus 2, we got change in y over change of x. It always turned out to be 1/2 between these 2 points, between these 2 points, and between these 2 points. But when we did the same thing on a nonlinear, the slopes ended up being different answers. Okay, I'll look at the other parts of this lesson in another video.